Thank you very much, Jonathan, for the kind introduction, and of course to the Bank of Israel for the invitation, and also all the participants that are joining now online. So this paper I'd like to present today was actually motivated before the big increase in inflation during the pandemic, and rather by a long-term trend that we observe in the data that is well documented both in macro and IO, that there's an increasing market concentration across many sectors, including retail. And one question that we had was whether this increasing market concentration and this increasing dominance of some large firms could actually have an impact on inflation, since these firms set prices. And we didn't find much of in the literature on this question. And this paper is really, I would say, a first attempt to address this question empirically, whether large firms could potentially have an effect on inflation and how that effect looks like. So this is a purely empirical paper. My co-authors are Santiago Alvarez-Blaser, Rafael Auer, and Andrei Levchenko. So let's see. So as an introduction, in our textbook, Monetary Economics Models that we usually write down, we know that inflation is fundamentally driven by aggregate factors, and there's no role for individual firms in aggregate inflation, mainly also because usually we would assume some sort of monopolistic competition, meaning that a single firm is very, very small and that a single firm therefore has no effects on aggregates. However, once we look at the data, and I will show you this also in our data, firms tend to be big. There are a few firms that are big, that have large market shares. And a second strand of the literature based on this paper by Xavier Gabex from 2011 actually looks into this effect of large firms, and in particular of the idiosyncratic shock of large firms. And they show, I will also show the literature in a second, they show quite convincingly that firm-level idiosyncratic shocks can have aggregate effects if the distribution of firm size is fat-tailed, that is, if we have a few firms that are relatively big. And this phenomenon became known as granular effects, or here in the paper of Gabex, originally he looked at GDP fluctuations. So this paper contributes to this literature by looking at inflation, and in particular it asks whether individual, what we call granular, these large firms, play a role for inflation. So what we do in this paper, as I said in the beginning, it's a purely empirical paper. So we look at barcode-level home scan data set for different countries. We have over 16 countries in our data set, with information on the product category, the firm, which is important because many other micro price data sets price data sets underlying the calculation of the CPI usually don't include identifiers of the producer or the firm, which we have. And I will show you this important. And also, as an extension, we have information on the retailer at which a product was purchased. So we observe prices, quantities, product categories, producing firms of different products, and retailers at which consumers buy. We will decompose the aggregate inflation rate into multiple what we call granular residuals. That is the contributions of these large firms to the aggregate inflation. Now, what we find, just in a nutshell, we find that inflation can be granular, mainly in low inflation environments, or mainly there this contribution is significant. Then the firm granular residual, that is the contribution of firms' idiosyncratic shocks to aggregate inflation, is the most important layer in these low inflation environments. And also in this extension where we look at retailers, we also find that retailers have some granularities or granular effects. When we looked into the post-2020 inflation surge, so we have first looked at the data before 2020 and then include the inflation surge to make sure that we're not capturing variation that only comes from the inflation surge, but we actually find that granularities contributed to this post-2020 inflation surge, also in countries that were previously at least more low inflation environments. And as a last point, if I have time to talk about this is still work in progress. We have some suggestive evidence that granularities also play a role for monetary non-neutrality. But this is an extension. If I have time, I will briefly talk about this. So to put this into the perspective of the existing literature, granularities have been shown to be important for several aspects in macro. That is, it has been shown that there are granular fluctuations that are important for aggregate GDP or productivity fluctuations. It has also been shown, and this is mainly the seminal paper by Gabex and follow-ups. It has also been shown to be important, for example, in international macro and trade, because we know that also in trade, trade is dominated usually by a few firms that are large, both exporters and importers. And there you also see on trade these effects of these granularities, these effects of the large firms or few large firms. Has been analyzed for the effect of government policies, and also in banking is also a typical market that is dominated by a few large banks. And there's a literature that looks at the effects of single bank shocks, for example, on aggregates. So that is the literature on granularity. And as I said, I think we're the first to look at inflation and the effect of granularities on inflation. Then we have a second strand of the literature that looks at mainly price setting in firms, in multi-product firms that typically produce, there are a few firms that typically produce many goods. And there's a finding that's also important for us, which we also replicate, is that price adjustments are strongly synchronized within firms. So there seems to be like a firm component, which will also show up in our data, a firm component in all the prices of the different products that a single firm sells. So that is an important finding. And again, I will not show you these results in detail. It's simply something that has been shown before in the prior literature that is cited here, both at the level of the firms, but also at the level of the retailers, that synchronization. And we also find similar effects in our data. So if you're interested, we have an appendix in the paper where we show these results. Now, let me just briefly walk you through the presentation. So we next talk in more detail about the underlying data, this multi-country product-level home scan data set. And then I will show you our granular residual and the decomposition first in a simpler form, and then I will show you different layers of this decomposition and different layers of granularity. Finally, I want to show the effect of these granularities that we identify on the post-COVID inflation surge. And finally, again, if I have time, I will briefly touch upon our work in progress, where we want to see what is the effect on monetary policy. And finally, I will just briefly conclude. So to the data, for those of you who haven't seen this type of data yet, we work with so-called home scan data provided by IMARC. The data is actually collected at a country by country level, GFKs, for example, in Germany, they run different panels of households, and these households have scanning devices at home where they scan the purchases they make, for example, in supermarkets and drugstores. So what we call fast-moving consumer goods, so usually very non-durable consumption. So what these households do, once they return from shopping, they basically scan the information they have on their shopping receipts, which would be a unique product identifier for a given product, the quantity purchased, and the price, and also the date of the purchase and the retailer. So that gives us the important information that we have. So directly from the data, the purchase date, the retailer at which product was purchased by a given household that is part of the panel in a given country. Then the unique barcode, which is important because that is exactly identifying unique products. So every product has a unique barcode. Typically, if you have like a bottle of water, for example, I have this here, then you see this barcode here, and there's a number below that, and the number is uniquely identifying this particular product, the size, the type, the taste, and everything. Okay, so that's really a unique product. Whenever firms change products, like product size or so, they would typically get a new barcode. Then we have the price, the units bought by a given household, the category, which is added by IMARC, so which category given barcode belongs to, for example, bottled water in the example that I just gave. And then what's also important for us is that IMARC also has information on, at the barcode level, which product was produced by which firm. So we have an identifier of the firm that produced a given product. In the set of countries that we include, so we have 16 countries overall, including both high inflation countries like Argentina. I'm sorry, Israel is not included in the data we got from IMARC, but we have Argentina, for example, or Chile, and then we have some more low inflation countries, the developed economies or advanced economies that we call them, Austria, for example, Belgium, Germany, US, Sweden, and so on. So overall, again, it's 16 countries. We have data from 2005 to 2022. However, in the first years, we have some missings for some countries. We don't have data there, but for most countries, we start our data set in 2008 and then up to 2022. What we first do is we aggregate all our observed prices and quantities that we have, which is now basically at the household and date level. We aggregate all that up to a product level data set. So we now have a product level, and then year-on-year price changes, so it's quarterly. We aggregate everything to the quarterly level, so it's such that we have, for every quarter, we actually observe an average price or a modal price. What we use here is the modal price to take out a bit effects of sales. A modal price for each product I in a given country C for a given category G and produced by firm F. So this is here, our sub-index is this product, category, firm, country, and time. And again, time would be a quarter. Then of course, we compute price changes such that we have product level year-on-year price changes. So now we have these product level year-on-year price changes. Next, we aggregate our quarterly inflation for quarter T and country C up to an aggregate country level inflation using weights for each product, which we take from the total expenditures that we get for each product. Since we want to compute Laspere weights, which are close to, which is close to most official statistical offices computations, we use the lagged weights, so by 4-quarter initial period weights, again, which we compute at the product country level, which we compute from our expenditures that we observe in the data. So that means that what we have, and this is important, we will look at inflation, which will be the sample inflation we compute here. So we will treat this change in the country level or the weighted average of all these price changes in a given country. We will treat this as the aggregate inflation. I will show you that our sample inflation is actually close to what we get from official statistics for these different countries. So we can match these official statistics quite closely, which makes us confident that we can actually use this as our aggregate inflation. I will show you this in the next slides. Also, what's important, we focus on firms. By firms, we really mean firms by ownership and not brands. Like, for example, if you or suppose you have a firm that is Unilever, and then Unilever owns different brands like Dove, Knorr, Ben & Jerry's, and so on. So it always focus what we call firm with Unilever and not the brands. There's
Sarah?
a question. Yes?
Yes, so there's a question from Fejawadi.
Yeah, thank you so much. Can you hear me?
Yes.
Yeah, maybe a couple of questions, but a couple of small questions, basically about the sample. So you focus on 2005, 2022, then or 2008, 2022. But we know that during that period, the dynamic of the inflation is different, and even the drivers of the inflation are different. For example, let me explain what I mean. For example, if we know that the COVID period, like 2020, 2022, it was like caused by this, caused more by this pandemic, this rapid recovery, and so on. There's a kind of shock, and for that period, for example, you see that the inflation as a whole is more driven by foods prices, by commodity prices, and so on. So I don't know how do you handle that. Why you did not decompose the inflation into separate, like before the COVID and then the period of the COVID, to see whether this firm is to impact with the same way. And also about the sample inflation. So how did you define it? Which are there a kind of test done to see what you have to include, food, beverage, personal care? For example, why not the commodities in the sample inflation? Thank you.
Yeah, thank you. So on the first question, I completely agree that the COVID pandemic was really different in terms of how we think about inflation and what contributed to inflation. So that's also why we did the initial, I will show you the initial period really without the COVID pandemic up to 2020, and then showing which countries these granularities mattered and to what extent. And then I will extend it to just looking at the 2020 to 2022 period, exactly to see if, since the COVID pandemic had all these quite unusual dynamics, also in terms of inflation, whether there's anything different in this period. That's also why we included it separately. On the second question, it's true that here, that's why I highlighted also this here in this third point here. Inflation is really sample inflation. So we only have at this level of detail, including real prices over time for given unique products, where we also observe firms. That's pretty unique to this home scan data set. And their consumers only in this home scan data, really, they only scan products for these fast-moving consumer goods. I think for some countries, there are extensions of the data where you have also consumer electronics, but that's not what we have here. So we really have to stick to the sample that we're provided with. Again, it's mainly inflation, food, beverages, personal care items. So it's the type of stuff that you typically would buy in a supermarket or in a drugstore. I think we can still learn something from this. I mean, it's an important component still in many countries, both in advanced economies, but also in emerging markets, the food, beverages, personal care items, and so on. And it's also a market, I think, if we think about extending these results to other categories like cars and so on, other consumption categories that are not included in our sample, but would be included in a typical CPI. You could also think of many categories as being dominated by a few large firms, like, for example, cars would be dominated usually by a few large car producers. So I think it could be extended once we would have data on other categories, other or broader categories that are included in the CPI. I think the results could still be applied to these other categories. But it's true. I mean, that's also why I wanted to highlight it in the beginning. We look at inflation that is computed from this data. So once when I will talk about inflation and aggregate inflation, I will refer to this delta PCT. In the next slide, I will show you. I mean, I think it's a good way to go to the next one, that it's actually quite close to what we have from statistical offices once we compare that to inflation numbers from the statistical office. So I think the data is representative, but for that specific group of products and categories.
Thank you.
So before I come to the comparison with the official statistics, let me first just give you a brief overview of the underlying data sets. So what we have is overall quite a big number. This is in million of observations of unique transactions, which is the raw data that is underlying our calculations. Then once we aggregate everything to the level of price changes, where we need a price, so a quarter in a given year, and then the same quarter in the next year to compute the year-on-year price change. Here are the number of observations that we have. So overall, we have about 52 million unique price changes aggregated across all the countries. You see that, of course, we have more larger samples in, for example, the US and in the bigger economies, Germany, France, and so on. So that's kind of natural coming from the larger size of the samples, the household samples from the underlying data. Here you see the number of firms. Again, many firms, of course, in the larger countries compared to the smaller ones. The number of products. And what's interesting, if we compare the mean of products, so how many products are produced on average per firm, it's around, in the entire sample, it's around 22 products on average are produced by a single firm. But once we look at the median of that distribution of the number of products produced by single firms, it's only 2. So that already suggests that there are a few firms that have produced many products, and there are many firms that produce only a few products. So that's already suggestive that there's quite a heterogeneity underlying in terms of firm size, or at least in terms of numbers of products produced by given firms. So when we compare the data that we compute from our scanner data to official data, I show you here first over time an example for Germany. We have in the appendix all other countries. It looks similar for the other countries as well. I will also show you a scatter plot that includes all the countries. So when we compare the delta PCT that I showed you before, the inflation rate that we compute from our scanner data, that's here the solid black line, and compare that to the official data from the German Statistical Office for the matched categories. That is also for similar product categories as we have in the data set, either with the weights that are used by the German Statistical Office, or we could also use the weights that we get in our data. You see that these co-move very closely. So we capture the dynamics of inflation in these categories really well with the data that we have when we compare it to the official statistics. So this is only for Germany, but also when we do this for all countries, and now we have here on the left-hand side, I have here the official year-on-year inflation plotted on the horizontal axis, on the vertical axis, the year-on-year inflation we get from the scanner data, and then the red line is simply the 45-degree line. And you see that most dots align well with this 45-degree line. Now, one dot is a given country quarter observation. And you see, again, for most countries, here are a few outliers that have very high inflation. I will show later on, this is from Argentina. But for most of the countries, we're really well aligned with this 45-degree line. Also, when we compute this in a pooled way. So if we do a bin scatter here, we also see that these numbers that we get from our data are quite close to what we see in official year-on-year inflation for the same categories. Now, an important ingredient in just assuming that there could be effects of granularities or of these large firms is, of course, that the firm size distribution should be fat-tailed. That's well documented in this granularity literature that I've referred to before. And when we plot the market share of expenditures, this is in percent, and this actually is a log scale. Here we first plotted for the US, that's the blue dashed line, and then all other countries are shown as these gray solid lines. And again, we have here a log scale. So we put the actual market share here, but on a log scale. Otherwise, so it's so skewed that it would be even difficult to show in a figure. That's why we put the log scale. But you see, even on a log scale, there's a huge market concentration. So there are a few large firms that have really big market shares, and there are many firms that have very, very tiny market shares. Just to compare this to the typical model that you would write, if we think about inflation, we usually have a model that has monopolistic competition. You have a continuum of firms, and all firms are super small. So if we compare that to the typical model that we use to think about inflation, we would actually have a huge spike here at super low market shares. And you see, this is what we see here. The data is vastly different to what we assume in such a typical model. Now, just to put some numbers to highlight this market concentration, and that it's important not only like in US or a few countries, but this is really across the board in all the countries that we study. Overall, the 10 largest firms that we have an average market share of around 40%. So only 10 firms have 40% of the market share. Just in the US, 10 firms cover 31% of expenditures. In Germany, it's even more extreme. Germany, we have 44%, so almost half of the entire market share is owned by these top, by the biggest 10 firms.
Is it a good assumption? Can we assume that it's the same 10 largest firms in all the countries?
No, it depends on the country. Some firms, I mean, there are some international firms. Yeah. I'm not allowed to tell you exactly which firms are which due to data confidentiality. But I can tell you that there are few firms that are international firms. If you think about what you buy in the supermarket, I think it's kind of you can make an educated guess which firms these are. And there are a few international firms that show up in all countries. And then there are a few firms that are maybe more market specific. So some European firms that wouldn't show up in the US and vice versa. Yeah, but there are a few international firms that show up in all countries in these 10 largest. Yes. Yeah.
Okay, thanks.
So, and when we just look at, instead of the top 10 firms, the top 1% of firms, they actually have an average market share of close to 80%. So these are really huge deviations from, again, this typical assumption that we would put in a standard Keynesian model where we would have monopolistic competition. So there, we could actually say, yeah, it's taking together this evidence on this distribution of market shares as a measure of distribution of firm size, and the fact that these large firms also tend to have, say, a common pricing component across all their products, we could actually assume that there could be effects of granularities. So just to start with a simple warm-up, suppose we have our aggregate inflation. Again, I'm repeating here the formula for aggregate inflation, a Laspere type price index, a weighted average, given the lagged weights, a weighted average of all product level price changes that we observe in a given country C, in a given quarter T. So let me first start with a simple granular residual decomposition, simply by adding and subtracting from this weighted average, simply by adding and subtracting the unweighted average of these product level price changes. And that is already the first, I would say, simple granular residual decomposition. I will give you a bit more intuition why this makes sense in a second. So the simple granular residual decomposition would decompose this inflation rate into a component which I will call the aggregate component. That's the unweighted average of these price changes. And then the difference between the weighted and the unweighted price changes. So here the intuition is that, and this second component, that is actually our granular residual. Again, a simple granular residual, I will come into more refinements in a minute. So the simple granular residual, you see it's the difference between the weighted and the unweighted average. And that simply would be zero if, for example, all weights would be the same, then these two would be the same and just cancel out. Or if all price changes, for example, would be the same, was also the granular residual wouldn't matter. So the granular residual can be positive or negative, depending on whether we see a systematic covariation between the size of a given, here it's simply a given product, the size of a given product, the expenditure weight, and its price change. So that would lead to a positive or negative granular residual. Now, so there must be some systematic variation for the price changes of, for example, of the large firms. Now, let me go into more detail. So where, as I said, I will give you some intuition for this, where this has come from. Suppose that each barcode level change, so just to give an intuition, would be the sum of an aggregate component, that is due to aggregate factors, and an idiosyncratic shock, product level idiosyncratic shock, that has a mean of 0. So the change in the product level price is simply the sum of this aggregate component. That's why it has the C here, the country level aggregate time component, and then a mean 0 idiosyncratic shock. And because the mean 0 idiosyncratic shock simply means that the weighted average of this idiosyncratic shock is 0, then when we plug in this definition, simply sum of the aggregate and idiosyncratic component, into our decomposition that I just showed you before, that we take the unweighted average and then the difference between weighted and unweighted as the aggregate component and the granular residual. This reduces to this equation here, where we see that the unweighted average of a single price change, or of all price changes that we observe in the economy in a given time period, if we take the unweighted average, this idiosyncratic part drops out, and we're simply left with the aggregate component. So that is our unweighted average. That's why we have this here. And then what we're left with as a granular residual is simply the weighted average of these idiosyncratic shocks. So again, if all firms would be equally sized, this would be 0 by definition. If there's a systematic relationship between firm size, this expenditure weight, and the idiosyncratic shock, then we actually would see that the granular residual could be non-zero. So that is just a simple intuition how we think about this granular residual and why it makes sense to do this difference between weighted and unweighted product level price changes. Now, let me show you just for, again, it's a simple granular residual. It does not yet take into account that, for example, there could be different product categories that have different weights. I will do that next. But just to look at this, the decomposition of the simple granular residual. And here we plot, again, for Germany as an example, here we plot inflation, again, the product level or the scanner level inflation that I showed you in the beginning that we compute from our data. That's here the solid line. And then here the dashed dotted line. That's our estimate of this simple granular residual. And you see that the dynamics of the granular residual are actually coincide quite well with the aggregate inflation dynamics, suggesting that this granular residual could be important for aggregate inflation dynamics. Now, of course, this could be simply that there's, I would say, some, for example, 1 or 2 really big product categories that people consume, and this is simply a category level granularity and not really something that is related to, for example, firms. So in the next step, come to these charts later. In the next step, I would decompose our product level or our aggregate inflation, our aggregate sample inflation, again into category granularity and firm granularity, and then also an extension into a retailer granularity, such that we know whether the granularity that we observe is actually coming from the large firms or the large retailers, or, for example, the large categories. It could come from, just mechanically, it could come from all of these different layers of granularity. So what we do next, in order to take into account these different layers, we extend this definition. So we decompose our aggregate inflation rates. And first, what we do is we say that our product inflation depends on first an aggregate, a firm, and a category-specific component. So here we define our change in the product level prices as the sum of some country level aggregate component, the delta CT, similar to before, which is the same across all the products in a given time period in a given country. Then we have here, or let me go first to the deltas. Here we have a firm component. Think of it like a firm fixed effect in a given, or firm time fixed effect for each country. Then a category component. And then we also allow for the fact that, for example, different firms could respond to aggregate factors differently. So what we have here is a latent aggregate factor, and we estimate here different firm loadings on the aggregate factor. And the same for the categories. We have a category aggregate factor, and then here the lambdas, different loadings of different categories on the aggregate factor. So that allows firms and categories to have different responsiveness to aggregate factors, in addition to simply a firm fixed effect and category fixed effect in a given time period. So when we insert this definition of our product level price change that is decomposed into these different layers, aggregate, firm level, and category, we insert this definition into our definition of the aggregate inflation rate, again, simply the weighted average of all these firm level price changes. And that gives us the decomposition into, again, this aggregate component, the delta CT, which is the same across all the products, then a firm level granular residual, and then a category level granular residual. So what we now have is that we can decompose, given this, this definition, we can decompose our aggregate inflation into this unweighted average, again, the aggregate factor, a firm level component here, and the category component. Now, how do we do this in terms of estimation? Here, I show you each step in detail, how we estimate these, the firm components and the category components and the aggregate components. So what we first do, we project our product level inflation rates. Product level inflation rates. Again, we do this everything country by country. The product level inflation rates on category time fixed effect. That's the delta GCT here, or the delta hat GCT on a firm time and on a firm time fixed effect. So we estimate this fixed effects. And then we define our aggregate component as the unweighted average of the category fixed effects plus the unweighted average of the firm fixed effects. And then we define here this delta tilde for each. So D here is either category or firm for firms and categories. By subtracting the unweighted average or by demeaning these estimates of our fixed effects from this first step. So then we have the average category and the average firm component are zero in every period by definition. So the delta DCT, the delta tilde is zero by definition in each period. And then in the last step, we want to allow these categories and firms different loadings on a latent aggregate component. And we do so by estimating a common factor using expectation maximization, PCAs. So for example, for the firm, do the same for the category. We have here this PCA, so that that decomposes our delta tildes into this responsiveness to aggregate or differential responsiveness to aggregate factors, the lambda etas here, and then the firm specific, basically from fixed effect, the deltas here. So that allows us to obtain an estimate of firm's heterogeneous response to the aggregate factor. And again, we do the same not only for firms, not only for the Fs here, but also for the categories. Let me skip this and show you directly the results that we get from our decomposition. So again, I do this for Germany. I will also show you the US and Argentina. And then we have all the other countries are in the paper, in the appendix, which you can find on our websites. So the inflation is here, the black solid line, again, simply what we compute from our underlying data, sample inflation. And then we have the decomposition here. I called this U before, it's M here in the figure, I still have to change this. So this here is our aggregate component. that is this joint component across all the products in our sample and in the data here for Germany across all the products. And then we have this category granular residual, this red dashed dotted line, and then here the firm granular residual with the long dashed blue line. And you see that even though, of course, most of the inflation or the dynamic is clearly driven by the aggregate component, these two granular components are not unimportant. So they're not at zero. They actually fluctuate, and they also contribute. I will show you more statistics on this just to visualize it. They also contribute to some extent to the aggregate inflation dynamics. How much, I will show you in a more detailed variance decomposition next. So this, for example, is in Germany. We see there's some significant effect of the granularities. Now, let me show you a similar figure for the US. Also here we see that the granular component, the firm component, which will come out to be more important than the category component in the next part, is actually showing up mostly here also on average positively. Now, these are two countries that had at least up to, in the sample that I show you here, up to the pandemic, up to the end of 2019, had on average quite low inflation rates. You see here the scale, this is to maximum 4%. Okay, same for the US, relatively low inflation, as we all know in this time period. Now, if we think about a country, and here I have Argentina, which is the country with the largest inflation in our sample, and you see here the average is between 20 and more than 40% over the same time period. And what's interesting to see is that even though the granular residual, in terms of the size, it's actually on average similar to the ones in the low inflation environments. We see that here, for example, Argentina, the big or the high inflation that we see here is actually mostly due to aggregate factors, to the aggregate component. And this firm granular residual contributes only relatively little, mainly because the high inflation is mainly due to the aggregate factor. I think that's also an interesting finding. Now, as I said before, I will look at more to put more detailed numbers on this decomposition. Let me show you the contribution of the firm granular residual to the aggregate inflation variation in these different economies. And I will compare first advanced economies. So I only have the advanced economies here in this table, and then the emerging markets that we have in the sample. So here you see what I highlighted already in the figure. We have a relatively low average inflation in that time period. Again, this is only up to the end of 2019. And we have an average inflation of 0.84, so very low inflation environment. And here, so I show you here the mean of each of these different components that we estimated. Here again, the aggregate component, here the firm granular residual, here the category granular residual. And at the end, we will, I think what's most informative is to think about what is the variance share of each of these components. This is a result from computing Shapley values. So here we have that 44% of the aggregate inflation that we observe are due to this aggregate factor that we estimate, so that the factor is common across all the products. Then, however, the firm granular residual also contributes almost equally, a little bit less, but almost equally, also roughly 40% to the overall variance in inflation, in aggregate inflation in our data. And then you see here this fact that I highlighted before, that the granular category residual actually also contributes, but relatively less, only about 15% to the aggregate inflation variance. Now, this is different, for example, to the emerging markets that we have in our data. We have less countries from the emerging markets this is based on less observations, but I think the overall pattern is really clear just from looking at the figures. So we have much higher inflation up to 2019 already in these emerging market economies. So we have 6.7% average inflation across all countries and time periods that we have here in the data. And you see when we look at the variance share, most of that is due to aggregate factors, like, for example, monetary policy shocks or other shocks that impact all the prices of all products in the economy. So roughly 80% is due to the aggregate component. Only 20% is due to the firm granular residual. So there is some contribution, but it's relatively low compared to the low inflation economies. The category component is actually completely unimportant in these emerging market economies. Now, one test for this interpretation of granularity, and that is related to market concentration, is to show this correlation between first the average weight or the average market share of the largest 10 firms and the contribution of the granular firm residual to the variance of aggregate inflation in these different economies. Again, everything is up to the end of 2019 in the data. So here you see that there is a positive correlation suggesting that countries where we see that the top 10 firms have a large market share, like, for example, here Netherlands, UK, or Belgium, also tend to have a large contribution of the firm granular residual to the inflation variance. Again, consistent with our interpretation of this firm granular component. When we look at the relationship between the actual level of the inflation rate and the firm granular residual, we have here two illustrations. On the left-hand side, you see a relationship between the aggregate inflation here on the horizontal axis, and here on the vertical axis, the granular residual, the granular firm residual. And you see there's, at least for when we look at all countries, there's some positive correlation. Here's the fitted line. But of course, when we look at the difference between the advanced economies that all tend to have the lower inflation rates and the emerging markets that often have on average higher inflation rates, we see that the contribution or the correlation is much higher in the advanced economies. Again, consistent with the illustrations and the figures of these time series that I showed you before. Now, on the right-hand side, we have...
Sarah?
Yes?
Yes, we have more or less 10 minutes.
Okay. Then let me... Yeah, I think that's... Let me continue with this figure, and then I speed up a bit. So here we have on the horizontal axis, here on the right-hand side of this of these figures, we have the average, again, the average inflation across computed for each country over time. And here the variance share of the firm granular residual. And you see there's clearly a negative relationship. So we see that countries that tend to have high inflation on average tend to have a lower contribution of this firm level granular residual, again, consistent with the figure I showed in the beginning for Argentina. Here we exclude Argentina because it's very much out in the out here. But still, even excluding Argentina, we see this negative relationship, so that the contribution of these firm granular components tends to be much more important in low inflation environments. Now, let me just briefly talk about the role of retailers, because an obvious question could be, yeah, well, maybe what you find is actually a concentration of retailers that tend to sell, for example, certain products. And we know that there's also quite some concentration in retail markets in the countries that we study. So also these markets at the level of the retailers, like Walmart, for example, tend to be dominated by a few large retailers. So we do the same decomposition, simply add an additional term for the retailers. Now, why don't we do this from the beginning? We have a smaller sample of products because there's some, for some countries in our data, there are a lot of missing information on the retailer, simply not there in the data. And it could be that these are really super small corner stores, but it could also be simply that the retail information is not consistently collected. That's why we actually went first for the larger data set that we could study, where we have the firm level information and the category information consistently. And then now in a second step, we have to reduce the data due to missing information, and also in order to get some estimates for the retailer component. So we do the same decomposition, and we simply add also the contribution of the retailer, similar as, or exactly the same as for firms and for categories. Now, when we look at this decomposition, we see that again for Germany, also the retailer component, which is here this last part here, is not zero over time. So there's some fluctuation. There could also be some contribution. I would just show you, in the interest of time, this variance decomposition. Again, the aggregate component, of course, now there's some reduction in the aggregate component, which could come both from the reduction in the overall data set. You see that the inflation that we have in this reduced data set is slightly higher, but also from the addition of the retailer component. But you see still that around 1/3 of the variation is due to the aggregate component, roughly 1/3 is due to the firm component, and then almost equally sized, around 16 to 17% contribution to the aggregate variance is due to category and then retailer component. So the retailer component contributes something, but it's clearly less important for the overall inflation dynamics compared to the firm component, which is also why we focus mostly on the firm component.
We have a question from UT.
Yes, hello. I was curious. I mean, you're looking for the components of the contribution for the aggregate inflation, and how would it differ if you were also separating based on separating the product level information based on their concentration, maybe? So I assume there are several products that are produced by in a highly concentrated market, and how much does the firm level inflation affect their overall aggregate inflation versus those that are produced by large amount of firms? Because it can happen that for them the firm level component is much more, and that can also affect the inflation expectations, which would eventually affect the aggregate inflation. Yeah, just I'm asking if you, instead of looking to aggregate inflation, you focus on inflation in meat, let's say, versus inflation in bottled water. And inflation in meat, if it is produced by few firms, for them, the firm component would be higher, I assume. So you didn't do that kind of an aggregation. So I mean, you changed the inflation by category. Just estimate
just in the estimation,
categories.
Remember that we take out or that we basically control for category level stuff. That happens only at the category level for all categories together. So what you're wondering is if there are firms, say that there are only 3 firms in a given category, and how
Yeah.
If that basically component? A part of the firm granularity could actually end up in this category effect. Right?
Yeah, but
yes.
Yeah, but then you don't need to put the category effect. You just look for the aggregate effect and the firm effect. And for the specific category, firm effect could be higher in specific categories.
It could be higher, yeah. I think if we do it category by category and look at firms within categories, most likely the firm specific component would be even higher. Because simply market concentration, if we think about this not as like this aggregate retail sector, but really like category by category, then category by category, of course, the market concentration would be even higher, and therefore the firm component would most likely be even higher.
Because the other the other categories might be dimming the effect if you look at aggregate inflation, because there are some categories where the firm effect is very low. And since you're looking at the aggregate, it can be lower. Okay, thank you very much.
Thank you. So let me maybe jump a bit ahead just to show you like the last result that I want to highlight is this contribution of the granularities during the most recent inflationary period, 21-22. So we did the same decomposition as before, and now on the 2021-2022 period. Since we only have 2 years, there's only 8 quarters of data, we will not look at the variance or the share, the contribution of to the variance of inflation, because we have such a limited time period on the 8 quarters. We'll just look at the contribution of our different granular components to the average inflation in that period. Here for the advanced economies, you see that, again, this was the result from before as a comparison, 2008 to 2020, average inflation low, 0.84. Now 2021, 2022, inflation, of course, we know is much higher. On average, is roughly a bit below 4% on average in the advanced economies in these 2 years. And when we look at the contribution now to the average or the share of the average inflation contribution, we see that the aggregate component again is roughly 40%, and that the firm level component is now quite important. When we do the same measure, just the contribution to the average instead of the variance for the firm level component from 2008 to 2020, it's only 20%, and we see here it goes up to almost 40%. So these granularities were actually quite important in the advanced economies in this recent COVID period. And as we know, this has been a very different inflation dynamic due to many different factors. Of course, also aggregate factors, as you see here, aggregate factor again is the most important one in this time period. Again, contribution of categories is a bit higher than in the pre-COVID period, but not all that much as compared to the increase in the contribution to the firm component. For emerging markets, we have similar results as we had for the low inflation period, that what mainly drives aggregate inflation, both on average and in the variance, is really the aggregate factors, the aggregate component, and not so much the firm or the category component. So just to wrap up briefly, so what we find in this paper is that there's clearly distribution of firm size that it is right skewed. So I showed you these distributions. 30 to 60% of the expenditures go to the 10 largest firms. So it clearly deviates from the standard macro model that we use to understand inflation. When we look at the contribution, again, purely empirically, of these granular residuals that we identify to aggregate inflation, we find that they are important for the variance of inflation, for inflation dynamics in these advanced economies, in low inflation environments, not so much in the emerging markets. And we find that there's a correlation between market concentration and average inflation, and these cross-country differences in the contribution of this firm component to the inflation variance. Now, we find that the granularity is most important at the layer of the firms. Also retail and categories are important, but the most important layer is actually the firm granular component. When we looked at the post-COVID inflation spike, we find that these granularities actually contributed to this post-COVID inflation spike. That does not mean, by the way, that it's anyhow related to this greedflation story. So we don't have much to say about this, because for testing greedflation, we would actually need markup data, which we don't have. So we can simply say this firm component contributed to aggregate inflation, but whether it's costs or markups, we cannot say, because we cannot tell apart. We only have prices and not costs and markup. By the way, Santiago, my co-author here, has a very nice paper together with Alberto Carvalho and Alex McKay exactly on that question on greedflation, and they have markups and costs, so they can actually talk to this or have something to say about this greedflation part. And finally, we also have some, again, this is stuff here we're working on, suggestive evidence that granularity contributes to monetary non-neutrality, thus that it's relevant for monetary policy. That's all. Thank you very much.
Thank you very much, Sarah, for this very insightful presentation and results. So if we have questions from the audience, please raise your hand. I will start with my question, but you said it's a work in progress, but this is something very important for a central bank. You said that granularity contributes to monetary non-neutrality, but do you have some evidence about the transmission of monetary policy regarding granularity and concentration, and how monetary policy transmits to price products with respect to category or concentration? I don't know, but I think you can draw some results like that.
Exactly. That's exactly what we are currently working on. There are basically two approaches that we wanted to look at. The first one is the one that I was just briefly alluding to just look at sufficient statistics for monetary non-neutrality and look at the difference between weighted and unweighted. Again, it's very suggestive evidence. The second part we are currently working on is that we want to compute impulse responses to identify monetary policy shocks at the level of products or firms, and then again aggregate once equally weighted, and then aggregate with the firm weights, and then see whether we find different responsiveness to these policy shocks by the different firms. And that would, I think, speak very much to this question. Again, it's a part that we're still working on. But I think that's exactly the suggestion.
I do think that it could be very relevant for policy analysis. I will continue on my side, because related to the question from Fred Jawadi at the beginning, I think your presentation of the results is really related to the estimation, to the model you choose, and of course on the sample you choose. I don't know, maybe I would not say the word selection bias, but maybe there is something. So I will focus on one country, and I want to know, is the result that granularity impact the components of inflation is the result of a model or of the reality? And the second question is more related to the fact that, would you say, this is another conception, maybe a bit crazy, would you say that statistical institutions are biased or have an issue in measuring inflation?
So on the first part, so what we did is, right, basically the granularity that we estimate comes from looking at all these product level price changes, taking out this aggregate. Let me just call or talk about fixed effects. This aggregate fixed effect, and seeing whether we find some fixed effects at the level of the firms or the categories, and how they, once we put them back into, like, we just statistically decompose into fixed effects, and then seeing if once we put these fixed effects back into the aggregate,
but my question
we find this evidence of granularity. So is that dependent on the model? I would say this is a pretty, relatively few assumptions approach, right?
No, my question is related. When I said model, is all the things that you are using, for instance, the control variables, maybe there is something that is missing. I don't know. I hope not. But you know what I mean. I think you present, and it's probably true, that there is a reality. The reality is that granularity, whatever category or firm size, is impacting inflation. And what's happened is that all depends on a model, on an estimated model, which could depend on control variables and other features of the model. So that's more my question, the difference between your presentation and the reality.
Yeah, so I think one important assumption that we make, right, is that let's assume that this aggregate inflation that we compute is actually the true inflation. And once we assume that, I think all the rest is really just decomposing stuff. So we're not putting in any, assumptions about causality and so on. It's really just a pure statistical decomposition. If you think about control variables, I'm not sure if there's a control that I would use. I mean, again, everything will show up somewhere, right? It's a decomposition. So we have an aggregate part, firm part, category part, and then a very small residual part. And once we decompose, all these product level inflation rates are decomposed and then put back into this definition of the aggregate inflation. It's more or less, I would say, a relatively simple decomposition. What is, of course, what could make a difference is that we do this factor extraction, right? And we allow these different firms to respond differently to an aggregate factor, and also the different categories respond differently to an aggregate factor. When we take that out, our main result is not that different, because the main contribution to the variance actually comes from this firm-specific effect, and also from the category-specific effect, and not from this differential contribution, or not from this differential loading on the aggregate factor. So in that sense, I think it's a relatively low assumption environment. Again, if we don't allow for these different loadings, the main results are not all that different. So the main results really remain that this category firm residual is the most important one. We just reduce, I would say we reduce even its effect due to allowing for these different loadings on the aggregate factor.
Okay.
The second one, the statistical bias of the statistical office, I'm not sure. I mean, so we know that the last year price indexes anyways has some biases, right? Usually they're not first order, at least not in low inflation environments, but there's like substitution bias and so on that we could worry about. Up to first order, I think that the last year index is fine, and we're simply trying to use a similar price index or similar definition as the statistical offices, because we think it's an important comparison to compare that the data that we have is actually very similar to the data that we see from statistical offices. Again, one exception is the data that I showed you for let me go back to this part on Argentina. On this, I mean, there's some difference, right? So we have actually the official inflation numbers here are actually a bit higher than the ones that we have. It could be due to, for example, different weights, like the weights in Argentina might be updated at a lower frequency than annually. And there's, of course, in these high inflation environments, for example, substitution biases matter. I think for all the other countries, it looks quite well aligned what we have in the data and what they find. Is that answering your question, or?
Yeah. Maybe we can go further, or your co-authors, but I think the work of Cavallo on replicating the CPI indexes and stuff like that could be very, very interesting with the data set you have. And
that's exactly what we do here. So from the data that we have, I mean, Cavallo, I think, has more categories because they use online data. But from the data that we have, we do more or less exactly the same calculations as the statistical office to really try to replicate as closely as possible these categories that they collect with their prices and their expenditure weights. And you see, it's very similar to our weights and our prices that we collect.
Yeah, exactly. But you have different results. This is where it is interesting.
Yeah, but there are few deviations. So yeah. I think, I mean, we have a lot of products, more than the statistical office usually or would typically use to compute these categories. So it's not clear, I think, which one is true or which, I mean, it's really, I think that the difference is, I know for central bank, the difference is matters really if you're here or here, but I think it's difficult to tell what is measurement error and which one is closer to the truth. I think we have a lot of products, so I think it's not, at least not further from the truth, I would say.
Very interesting. Do we have any additional questions from the audience? So I will ask my last one, always asking this one, but as a central bank, we would be very interesting to know, what would you suggest based on your paper? Of course, put aside the monetary policy things that you are investigating, but maybe do you have some ideas about how to interpret or measuring how to measure inflation? What would you suggest to a central bank?
So I think one thing I find quite interesting, and I tried this out for a few countries just on the site, but I mean, usually you have, I guess you have this too in Israel, right? You have these detailed product category inflation rates, but for the aggregate CPIs, where you have like food and all the details, right? So one thing I find interesting as kind of a measure of this aggregate component of, like, I would call it maybe a core inflation measure that's really due to aggregate factors, is just taking the unweighted average across all these categories. So in the usual inflation calculation, right, you would take the expenditure weights and then weight up all these categories using the expenditure weights. I think I would just go to the most disaggregated data that you have, compute an unweighted average, and that gives you a good measure of this aggregate component. That is, again, it's in inflation that is due to aggregate factors, which I think is the relevant part for, or at least an important part, depending on what we find later on. But at least I know this is an important part for monetary policy, because that's due to aggregate supply, aggregate demand, policy shocks, and so on. So I think that would be an interesting thing to do. I would say as, like, probably I have a few core inflation measures, but maybe as an alternative to the core inflation measures that you have. Simple, unweighted average.
Okay, thank you very much. It was rich and very interesting. So if we have no other questions from the audience, I would like to deeply thank you, Sarah, for this excellent presentation and this fantastic paper. And we wish you best success for this paper and your next research projects as well.
Thank you. Same to you. And thank you very much again for the invitation. I'm very happy to be at the Bank of Israel, even if it's only virtually.
We would love to have you physically, but you know, the circumstances are quite complex. But thank you very much for presenting us this fantastic paper and being with us. And we hope to invite you for next papers that are as policy relevant as this one.
Thank you so much. Have a good afternoon. Thank you.
Thank you. Bye-bye.